Hello students, welcome to Choudhuri Academy. In this video, we are going to learn about heat from chapter 4 for class 7. I am sure, after watching this animated tutorial, all your doubts will be cleared. You will be able to answer all the possible questions asked from this chapter and of course, without reading dozens of books. Let's start the class.
Hello students, can you imagine how cold the earth would be if there were no sun? The sun is the earth's main source of heat. Only a little of the sun's heat reaches the earth. However, this is enough for life to exist on earth. Other sources of heat are fire and electric heater. In this lesson, we will study about heat and its measurements. At the end of this lesson, you'll be able to identify hot, cold, and warm bodies, define heat as transfer of energy, differentiate between heat and temperature, explain clinical and laboratory thermometer, explain effects of heat, identify modes of heat transmission, conduction, convection, and radiation, explain good and bad conductors of heat. The sun, burning fuels, electricity, and mechanical work are sources of heat. Let us perform an experiment. We keep tin or aluminium sheet out under sun and touch after some time. We then place the same tin or aluminium sheet inside the house. Touch the sheet after some time. In the first case, we feel hot, and in the second case, we feel cold. Let us prove through another experiment that sun gives heat. Use a magnifying glass to focus sunlight on a piece of white paper. At the position where the sunlight is focused, the paper becomes hot, starts to turn brown, and soon bursts into flame. Thus, the heat from the sun makes the paper burn. Man can generate heat by burning wood, coal, and gas. Wood, coal, and gas are called fuels. Fuels burn in machine to make them work. A motor car runs by burning fuel. An aeroplane flies by burning fuel. Electricity also gives heat. Man uses electricity to cook the food and to work the machines. Heat can also be produced by rubbing two things together. This is by doing mechanical work. Rub the palms of your hands together. What do you feel? You will feel that it is hot. The ancient man generated fire by rubbing two stones. You must have held both ice and hot cup of coffee. Why is it that in one you feel cold, while in the other it is hot? When heat energy from our body flows out rapidly, we feel very cold. This is the case when we hold ice. Ice on the palm gives a sensation of cold because heat from your body flows out of your body to the ice. With this heat, the ice on your palm melts. When the heat energy flow from outside into our body is rapid and more, we feel very hot. This is the case when we hold cup of coffee. The heat from tea or coffee flows to tea to the hand. Thus, it is the flow of heat energy which determines the cold or hot. Students, let us perform an activity to understand the concept of direction of heat flow. We place a glass of hot milk in a dish with cold water. After some time, milk gets cool and water gets warm. Both milk and water come to lie at the same temperature. Direction of the flow of heat is from hot to cold. Now we will learn the concept of temperature. Temperature is the measurement of hotness or coldness of an object. We say that water from fridge is cold and milk is hot. How much cold is water? Is it cooler than ice? How much hot is milk? Is it hotter than boiling water? Obviously, for this we need a measure to know about coldness and hotness of our body. A hot body is at a higher temperature than a cool body. When a substance is heated, its temperature rises. On cooling, the temperature comes down. Degree of hotness or coldness in a body is described as its temperature. The table shows the difference between heat and temperature. Heat is a form of energy. Temperature is a measure of heat energy level. Heat energy raises the temperature of a body, while the temperature decides the direction of flow of heat. Heat flows from a body at higher temperature to the body at lower temperature. Heat is measured in joules. Temperature is measured in degrees Celsius or Kelvin. Now that we have learnt about temperature, let us look at the device used to measure temperature. It is called a thermometer. The most common use of thermometer is to measure our body temperature. Such a thermometer is called a clinical thermometer. A clinical thermometer consists of a long, narrow, uniform glass tube. It has a bulb at one end filled with mercury. Outside the bulb, a small shining thread of mercury can be seen. A clinical thermometer reads temperature from 95 degree Fahrenheit to 107.6 degree Fahrenheit. The normal temperature of human body is 98.6 degree Fahrenheit. The clinical thermometer is also known as a doctor's thermometer. Precautions to be observed while reading a clinical thermometer are as follows. Thermometer should be washed before and after use, preferably with an antiseptic solution. Ensure the mercury level is below 95 degree Fahrenheit. Read the thermometer keeping the level of mercury along the line of sight. Handle the thermometer with care. If it hits against some hard object, it can break. Do not hold the thermometer by the bulb while reading it. Let us now discuss laboratory thermometer. A laboratory thermometer is used for measuring the temperature in a science laboratory. It is similar to clinical thermometer but is long and narrow. A laboratory thermometer reads temperature from -10 degrees Celsius to 110 degrees Celsius. Let us now measure the temperature of hot water kept in a beaker. Take a laboratory thermometer. Immerse the bulb of thermometer in hot water. See the shining thread of mercury moving up in the thermometer tube. After some time, the mercury thread will stop rising and stand at one place. Read the temperature on thermometer tube, which corresponds to the top of mercury thread. This is temperature of hot water. When an object is heated, it undergoes many changes. The object becomes hotter. The object may expand or contract in size. A substance may change its state when heated. For example, water changes into water vapor on heating. We observe a change in temperature on heating. On heating, temperature rises, and on cooling, the temperature comes down. In nature, the sun energy brings about a change in temperature. The days are warm, while the nights are cool. Summer is hot, winter is cold. Matter exists as solid, liquid, and gas. All the three states of matter expand on heating. The expansion of matter depends on the temperature through which it is heated. In this case, when we heat this plate, the higher the temperature, more is the expansion. Expansion of matter also depends on the size of the material being heated. The longer the plate or bigger the ball, more is the expansion for the same rise in temperature. The nature of the material being heated also plays an important role in expansion. For example, copper expands more than iron for the same rise in temperature. Liquids and gases are fluids. They expand on heating. Expansion in gas is very large as compared to solids or liquids. Let us look at some practical uses of thermal expansion of solids in daily life. The iron rim is fitted in bullock cart wooden wheels by heating. When the metal cools, it holds the segments of the wooden wheel firmly. A small gap is left between the rails of a railway track where the two rails are joined with the help of a fish plate. The gap is left to allow space for the expansion of rails in summer. Let us now look how heat affects the change in state. On heating, a solid changes to liquid and a liquid changes to gas. Conversely, on cooling, gas loses heat to change into a liquid and a liquid loses heat to change into a solid. The temperature at which a solid melts to change into its liquid form is known as its melting point. Melting point of ice is 0 degrees Celsius. The temperature at which a liquid starts boiling and changing into its gas state is known as its boiling point. Boiling point of water is 100 degrees Celsius. Perhaps you have observed that when a stove is lighted in the kitchen, the air inside the room becomes little warmer. If this air is allowed to come out through an open window, it gradually cools down. The metal stirrer left in the cooking bowl becomes hot. These examples indicate that the bodies at higher temperature lose heat and consequently their temperature falls. When bodies gain heat, their temperature rises. There is a mutual exchange of heat between bodies at different temperatures. Flow of heat takes place in a particular direction, that is, from bodies at higher temperature to bodies at a lower temperature as water flows from a higher to a lower level. There are three modes of transfer of heat from one place to the other place. These are conduction, convection, and radiation. Let us perform an experiment. Take a metal rod, hold one end and heat the other end. In the beginning, the end of the rod in the hand is not hot. However, very soon we find that the end becomes hot and we are not able to hold the rod any longer. It means that some heat has been transferred. The process by means of which heat is transferred in a solid body from one part to the other is known as conduction. Conduction happens mainly in solid. Note that conduction is not possible in vacuum. Remember that there are two important conditions for heat to be conducted from one body to another. These are: the two objects should be in contact and their temperatures should be different. The process by which heat is transmitted through a substance from one point to another due to the actual bodily movement of the heated particles of the substance is called convection. Convection of heat takes place in fluids, that is, liquids and gases, and involves the movement of matter from hot regions to cooler regions. In convection, heat is carried by moving gases like air and by moving liquids like water. A movement of air which carries heat from a warmer place to a cooler place is called convection current. There is a third way by which heat can be transferred from a hot body to a cooler one. This mode of transfer is called radiation, and it does not need any medium between the two bodies. All hot bodies radiate heat. The hot objects radiate heat rays to the surroundings. Heat from the sun comes to us by radiation. It travels through millions of kilometers of space to reach the earth. When this heat falls on some object, a part of it is reflected, a part is absorbed, and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. A cloudy night is hotter than a clear night. When the sky is clear, the heat radiation goes into the atmosphere, but due to the presence of clouds in the sky, these thermal radiations are reflected back to the earth and one feels warmer. Breeze is caused due to difference in heating. Let us see the cause for land breeze and sea breeze. During the day, land gets heated more than the sea water. Hot air above the land rises up, and therefore the cold air from the seaside moves towards the beach. This is sea breeze. At night it is exactly the reverse. The water cools down more slowly than the land, so the cool air from the land moves towards the sea. This is called the land breeze. Let us summarize what we have learned. You feel cold, warm and hot. Heat flows from hot to cold. Temperature is the measure of heat. A hot body is at a higher temperature than a cool body. Thermometer is used to measure the degree of heat in a body. Clinical thermometer is used to measure a body temperature. The range of this thermometer is 95 degree Fahrenheit to 107.6 degree Fahrenheit. For other purposes, we use laboratory thermometers. The range of laboratory thermometer is -10 degrees Celsius to 110 degrees Celsius. The normal temperature of human body is 98.6 degree Fahrenheit. There are three ways in which heat can flow from one body to another. These are conduction, convection, and radiation. In solids, generally the heat is transferred by conduction. In liquids and gases, the heat is transferred by convection. No medium is required for transfer of heat by radiation.
Thanks for watching. Hope all of you enjoyed it. Keep watching and keep learning. If you have any doubt, feel free to ask in comment section. Subscribe the channel Choudhury Academy. Also press the bell icon to get notified when we upload a new video. Share with your friends and family.